Hello my dear students, welcome you all, especially class 9th students. Today we are going to do the third exercise of chapter 4, that is linear equation in two variables. This exercise is based on the graphical representation of a linear equation in two variables. In the very first session of this lesson, we have seen what is the graphical representation of a linear equation in two variables. That is a straight line. That means if you find few solutions of a linear equation in two variables and represent them in a Cartesian plane, and if you join all the points, you will get a straight line. So let us start the exercise. The first question of the exercise is to draw the graph of the following equations. The first equation is x plus y is equal to 4. You know that this is a linear equation in two variables x and y. If you represent this linear equation graphically, that will be a straight line. For that, you have to find minimum 3 solutions for this linear equation in two variables. You know what is the solution of a linear equation in two variables? The values of x and y which satisfy this equation. To find the solutions, we can start with giving any value for x and substituting that value in the equation, you will get the respective value of y. That is, if x is equal to 1, then you substitute the value of x in equation, you get 1 plus y is equal to 4. Therefore, y is equal to 4 minus 1, which is equal to 3. If x is equal to minus 2, then the equation becomes minus 2 plus y is equal to 4. X plus y is equal to 4. Therefore, y is equal to 4 minus 2 will go as plus 2, that is equal to 6. You can give any value for x as well as a value for y also. Next, I give if y is equal to 1, then x plus 1 is equal to 4. Therefore, x is equal to 4 minus 1, that is equal to 3. So here we are getting simply 3 solutions of the linear equation, that is x plus y is equal to 4. We can write these 3 solutions in a tabular form as follows: x, y. If x is equal to 1, then y is equal to 3. If x is equal to minus 2, then y is equal to 6. And if y is equal to 1, then x is equal to 3. So here we have 3 solutions in the tabular form. Now these 3 solutions are going to be considered as the coordinates of 3 different points, and we will plot them in a Cartesian plane. Here I have made the Cartesian plane by drawing the x-axis and y-axis. Here the first point is x coordinate to 1, y coordinate to 3. X coordinate to 1 and y coordinate to 3 will be approximately here. Second point is minus 2, 6. That is, x coordinate is minus 2, y coordinate is 6. X coordinate minus 2, y coordinate 6. It is approximately here. And the third point is 3, 1. That is, x coordinate to 3 and y coordinate to 1. X coordinate to 3 and y coordinate to 1. It is somewhere here. So here I have plotted the 3 points in the Cartesian plane. Now if I join all the 3 points using a scale, we will be able to join all the 3 points using a scale, and it means that this is a straight line. That means all the 3 points are in a straight line. If you are not getting a straight line, or if you are not able to join these 3 points using a straight line, it means that you made some mistakes in these calculations. So here I am going to join them. Here you can see all the 3 points are in a straight line. So this is the graph representing the linear equation x plus y is equal to 4. Here we have to mention one more important information in the graph, that is the scale taken along the x-axis and y-axis. Here along the x-axis as well as y-axis, I have taken 1 centimeter is equal to 1 unit. So that must be written on the right top corner of the graph paper. Scale in x-axis and y-axis, 1 centimeter is equal to 1 unit. Remember, you can use different scales for x-axis and y-axis. If you use different scales, you have to write the different scales for both x-axis and y-axis. That is, in x-axis what is the scale and in y-axis what is the scale. So this is how we can represent a linear equation in two variables graphically, or how to draw the graph of a linear equation in two variables. The second question is, give the equations of two lines passing through the points 2, 14. How many such lines are there and why? Here you are given the coordinates of a point, that is 2, 14. X coordinate 2 and y coordinate 14. And you are supposed to write the equations of two straight lines passing through this point. If a straight line passes through the point 2, 14, then the equation of that straight line will be satisfied by x is equal to 2 and y is equal to 14. So you have to write two equations in two variables for which x is equal to 2 and y is equal to 14 is a solution. For example, x plus y is equal to 16. It is a very simple equation. If I write x plus y is equal to 16, and if you replace x with the 2 and y with the 14, you will get a 2 plus 14 is equal to 16. So this is an equation of the straight line passing through the point 2, 14. Similarly, you can write many equations for which x is equal to 2 and y is equal to 14 is a solution. Second is x minus y is equal to minus 12. Here x minus y is equal to minus 12 because if you replace x and y with the 2 and 14, then 2 minus 14 you will get a minus 12. So this can be written as x minus y plus 12 is equal to 0. So you can write more equations for which x is equal to 2 and y is equal to 14 is a solution. Here we are required to write two equations. So the two equations are x plus y is equal to 16 and x minus y plus 12 is equal to 0. Here we can have many such straight lines because through a given point, infinite number of lines can pass. If this is a given point, we can draw many lines passing through this point. Therefore, we can write infinite number of such equations. So, I hope you understood the solution for question number 2. The third question is, if the point 3, 4 lies on the graph of the equation 3y is equal to ax plus 7, find the value of a. So according to the question, the point 3, 4 lies on the graph of the equation 3y is equal to ax plus 7. given the point 34 lies on the graph of the equation 3y is equal to ax plus 7. It means that x is equal to 3 and y is equal to 4 is a solution of the equation 3y is equal to ax plus 7. That is, x is equal to 3, y is equal to 4 is a solution of 3y is equal to ax plus 7. Therefore, we can replace x and y with the 3 and 4 respectively. That gives 3 into 4 is equal to a into 3 plus 7. X is equal to 3 and y is equal to 4 is a solution, means in the given equation x and y can be replaced with the 3 and 4 respectively. Here I am replacing y with the 4 and x with the 3. We get 3 into 4, 12 is equal to a into 3, 3a plus 7. Plus 7 will be taken to LHS. 12 minus 7 is equal to 3a. That is, 3a is equal to 12 minus 7, that is 5. Therefore, a is equal to 5 by 3. So, if x is equal to 3 and y is equal to 4 is the solution of the equation 3y is equal to ax plus 7, then the value of a is equal to 5 by 3. The fourth question is, the taxi fare in a city is as follows. For the first kilometer it is rupees 8 and for the subsequent distance it is rupees 5 per kilometer. Taking the total distance covered as x kilometer and the total fare as rupees y, write a linear equation in two variables to represent this situation and draw its graph. According to the question, if a person hired a taxi in a certain city, he has to pay rupees 8 for the first kilometer and for the second kilometer onwards, he has to pay only rupees 5 per kilometer. And if the total distance is x kilometer and the total fare is rupees y, we have to write a linear equation in two variables to represent this situation and hence its graph we have to draw. So according to the question, given total distance is equal to x kilometer and total fare is equal to rupees y. Suppose if a person hires a taxi in this city and travels for 10 kilometers, he has to pay the total fare according to the following calculation. For the first kilometer it is rupees 8. Out of 10 kilometers, for the first kilometer it is rupees 8 and remaining 9 kilometers will be charged at the rate of rupees 5 per kilometer. So it will be equal to 9 into 5. For first kilometer rupees 8, remaining 9 kilometers are to be charged at the rate of rupees 5. So 9 into 5. So it is equal to 8 plus 45, which is 53. So here for 10 kilometers the total fare is calculated in two sections, that is for the first kilometer and for the remaining kilometer. Here for x kilometers the total fare will be calculated in the same way. Total fare is equal to rupees 8 for the first kilometer. Then for the remaining distance means x minus 1. If x is the total distance and for the first kilometer if rupees 8 is charged, then the remaining distance x minus 1 kilometer will be charged at the rate of rupees 5 per kilometer. So the total fare will be equal to rupees 8 plus x minus 1 into 5, that is x into 5, 5x minus 1 into 5 minus 5, that is equal to 5x. 8 minus 5, that is 3. So if x is the total distance, then as per the condition given, the total fare will be 5x plus 3. But according to the question, the total fare given is rupees y. Therefore, we can say that according to the question, y is equal to 5x plus 3. This is the linear equation in two variables representing the above information. Now we have to draw the graph for this. To draw the graph for this, we need at least 3 solutions. So here y is given in terms of x. So I am going to give 3 different values for x, and hence we will get the respective values for y. If x is equal to 1, then y is equal to 5 into 1 plus 3. That is 5 into 1, 5 plus 3, 8. If x is equal to 2, y is equal to 5 into 2 plus 3. That is equal to 5 into 2, 10 plus 3, that is 30. Third, if x is equal to 3, then y is equal to 5 into 3 plus 3. 5 into 3, 15 plus 3, 18. Hence, we have a table representing 3 solutions of this equation. The values of x are 1, 2 and 3, and the respective values of y are 8, 13 and 18. Now we have to draw the graph. In the Cartesian plane, I just highlight the first quadrant only, because all the values, all the x coordinates and y coordinates here are positive. So I just highlight the first quadrant. Now I am going to plot these points in this Cartesian plane. The first point is x coordinate 1, y coordinate 8. Here in the x-axis, I take the scale 1 centimeter is equal to 1 unit, and along the y-axis, I take 1 centimeter is equal to 5 units. So accordingly, you have to mark 1, 8. It is somewhere here. The next 2, 13. It is somewhere here. And third, 3, 80. It is somewhere here. So I have plotted all the 3 points. Now I am going to join them. So this is the graph representing the linear equation in 2 variables. Y is equal to 5x plus 3. The question number 5 is based on the graphs given. The question is, from the choices given, choose the equation of the graphs which are given in the figure. That means we are given 2 graphs. The first graph you can see, and in this graph you are given a straight line passing through 3 different points. The 3 different points are -1, 1, 0, 0, that is origin, and third one is 1, -1. So this straight line passes through 3 different points, 1, -1, 0, 0 and -1, 1. We have to select the equation representing this straight line from these 4 choices. Only one will be suitable for that. To find out that, we have to see for which of these equations these 3 points are the solutions, or which equation is satisfied by the x values and y values of these 3 points. Here clearly you can see that x plus y is equal to 0 is satisfied by all the 3 points. That is, if you take x plus y is equal to 0 and replace x with the minus 1 and y with the 1, minus 1 plus 1 is equal to 0. Or if you replace x with the 0, y also with the 0, 0 plus 0 is also equal to 0. And similarly here, if you replace x with 1 and y with the minus 1, then also you get a 0. So this is the only equation which is satisfied by all the 3 points. That means these 3 points, x is equal to minus 1, y is equal to 1, x is equal to 0, y is equal to 0, and x is equal to 1, y is equal to minus 1 are the solutions of the equation x plus y is equal to 0. Therefore, here the correct choice is x plus y is equal to 0. With this question, I wind up today's session. We will do the remaining questions of this exercise in the next session. Till then, take care. Goodbye.